Yo, I have a pencil. Of course you do.
Okay. Hearing nothing. Here's the bottom.
Oh. I did the correction. Bro, my bad. Okay, wait.
18. 18.
Are they on the board? Yeah. No, they're not. No. Now they are. 66.
Okay, are there any comments, questions, concerns about how I did any of those things? I mean, the work is there. Is there anyone who wants me to talk about any of those? Okay, going once, twice, thrice.
Right.
Sold. That's not the way it works, Jackson. Okay, last lesson. Here we go. Applications of exponents, roots, and BEDMAS, kind of all together in one delightful little package. So, the Pythagorean theorem. Hands up if at some point in your grade 8 experience you were taught this. A few of you. Okay, my first block said there's only 3 of them are like, yeah, we totally did this. I appreciate the higher level of involvement from you. You were supposed to. Appreciate the higher level of involvement. Yeah, you were supposed to. So let's review it, shall we? The Pythagorean theorem. Pythagoras was, I'm going to add a word in here. The word I'm going to add in there is allegedly. Allegedly. I don't know if there's 2 L's or not. When I Googled it, it said there was 2 L's.
That does look good. I think it's...
Nope, there's only 1 L. I misread. Allegedly.
Oh, here we are.
Why do you say allegedly?
I'm about to explain it, Marcus. So the way the ancient Greeks did education is that a person would show up, claim to have insight or wisdom. They might have been educated themselves. Guys like Plato, guys like Socrates, and then people would congregate to a teacher. They lived in a commune, and the teacher would teach. It would be like all of you decided that I was the math teacher that was going to teach you. So you all came and we lived in a building together, and you just hung out with me while I taught you math and we lived our life. That's how the ancient Greeks did education.
Whoa.
They'd find a person. That'd be weird. But they would leave, oftentimes they might leave their home, they would go and they'd live in a commune, and they'd learn from whoever this person was. So like Socrates learned from Plato, and like the wisdom gets passed on. These are names that you perhaps you know. Now, we know that a group called, sorry, did you ask a question, Priya?
So why did they put
Because you, no, we'll get there. We know that the Pythagorean plural, we know they were a group of people. They called themselves the Pythagoreans. We don't know for sure whether or not Pythagoras was actually a real person, but because of the style of the way they did education, if a group called themselves the Pythagoreans, there was probably at some point a dude, Pythagoras, that was the teacher for this group. We don't know for sure. We know Plato existed. We know Socrates existed. We know a bunch of these guys existed. We know the Pythagoreans as a group, but we don't know for sure whether he himself existed. But we'll go with it. We'll assume that he was. Pythagoras was a Greek mathematician, founded this group called the Pythagoreans. They were basically like a little fun math cult. Because what kind of cult would be better than a math cult? Like, come on. No sacrifices. We just do math. Sacrifice to math. So the one big result that they came up with had to do with right triangles and some squares.
Whoa.
So what they established, Jackson, was that the square of the hypotenuse, okay, well, first let's go back to some definitions here. This is a right triangle. What makes this triangle a right triangle? Sorry? How do you know that that angle is right? Someone said over here? Yeah, this angle right here, this sharp corner, is a 90-degree angle. It is. Because a full circle is 360, and so that is a quarter of a full circle. So 1/4 of 360 is 90. I can draw a pretty good circle. A sufficiently good circle. Not related to what we're doing right now. So we got a 90-degree angle right there. This is a right triangle then. One of the sides on the right triangle we can call the hypotenuse. We do call the hypotenuse. Do we know which one? Does anyone remember what side of that triangle we call the hypotenuse? The longer? The longest, yes. And the longest side is always the one that's across from the 90. I just wrote it on the board. HYPOTENUSE. Okay? It's also underlined right there. So what they found was that if you took the hypotenuse, if you formed a square out of the hypotenuse of a right triangle, this square is equal to the sum of the squares of the other two sides. I know, it's a little bit ridiculous. So let's draw this out again here. Draw me a right triangle. Bam. There's our right triangle. And what they did, they said, okay, well, these sides can all exist as roots of the side of a square. So we're going to draw some squares. The hypotenuse gets a square. This side gets a square. And this guy gets a square. Then what are we even doing here? It does kind of look like a cardboard box. And what they found was that if you took a right triangle, and it worked for any right triangle, which is the interesting part of this result. For any right triangle, if you take the hypotenuse and you make a square out of it, this area is equal to the sum of these two areas. So the big blue triangle, or the big blue square here, if you take the area of these two squares and you add them together, they found that for any right triangle, the sum of these two squares, areas, was equal to that one. To make this a little bit more useful, what we've done since then is we've added more letters to it. I'm sorry, Brielle. It's one of those things that this is not optional. You can say no thank you all you want. Letters are happening in math. Yeah. You rebuke. Well, I'll let you know how that works out. Hypotenuse, when we convert these ideas to an algebraic expression, we have to convert these sides, we have to give these sides names, and we use letters to name the sides. The hypotenuse always is what letter? It is C. In fact, it is C. We label the hypotenuse little c. L-I-L apostrophe C.
I have a question.
Yes, is it related?
Yes, why would it just be H?
Because it's C.
Why?
H is something else.
Why doesn't C be that something else?
Because C is also something else. I don't know, they just use it here.
Oh,
I don't know why. So if this side is C, does anyone remember what we call the other two sides? A and B. And it does not matter which one is A and which one is B. You could call this one A, and if that one's A, then this one's B. Or you could say, well, actually, no, this one's B and this one's A. It doesn't actually matter which one's which, as long as you're consistent. And so for the sake of this, I'm going to use these two green ones. So let's label these over on this triangle. Let's call that guy C, that guy A, and that guy B. So then what's the area of this blue square? If the side length is C, what's the area of the square? Yes. No. No. Well, yes, but no. Ignore the rest of the triangle for a second. That square has a side length of C. So that side length is, that area then is going to be C squared. Right? So this square is C this way and C this way. It's a square. All the sides are the same. So the area of a square is length times length. So it's going to be C times C, but we're in the unit on exponents. So C times C is C squared. So then this triangle here, this square here is going to be A squared. And this triangle down here, square down here is going to be B squared. And this is where we get the idea. We get rid of the picture and we say, okay, we can use this formula then. A squared plus B squared equals C squared. And this is something you were supposed to have learned in grade 8.
Oh, I kind of.
They may have tried to.
I don't think so. I don't think so.
Okay. This can be rearranged.
I still remember angles.
You guys did some algebra in middle school. You moved things around. This equation here is useful if I know A and B and I'm looking for C. But what if we know C and one of the other sides? What I can do is I can get one of these two, either A squared or B squared, alone by doing what? How do I move it to the other side of the equation? Who remembers their algebra from grade 8? Sorry? Gershon did just answer it. Gershon, don't answer it again, because I don't know if other people heard you. The question, Brielle, was, how do I get A squared or B squared alone on this side? They are being added together, so I'm going to subtract one over. So I can take, if I want to get A squared by itself, I could just take B squared away from both sides, and we would get this equation. A squared equals C squared minus B squared. If I wanted to get B by itself, I could have just done the same thing with the A. I could have said that B squared equals C squared minus A squared, depending on what you're looking for. Which is a unit we've got coming up. Algebra is coming up. So let's do 2 examples, and then I'll give you some time to work on a couple questions. Here we go. So I want to find the missing side of the following right triangles. We're going to label the sides first. So I got that triangle on the left. It is one side length is 2, one is 3, and there's a question mark. How could I label those sides? The only label that matters is C. Which side is C? The question mark. Thank you, Gershon. That side is always C. It does not matter which one of these is A or B. Let's go like that. So then if we're looking for C, because that's where the question mark is, the equation that we're going to use is this first foundational one. A squared plus B squared equals C squared. And what I'm going to do here is I'm going to draw an arrow up there and I'm going to use it. The equation, I mean. So how long is side A? It's 2. So I'm going to take 2 and I'm going to put it where A is in this equation. So we're going to get 2 squared plus B is 3 squared equals C squared. And I want to solve this thing now for C. BEDMAS says, what do I have to do first? The exponents. So 2 squared is?
4.
Plus 3 squared is? 4 plus 9 is? So 13 equals c squared. But I don't want c squared because that's the area of the square. I just want the side length. So what do I have to do to get just c, the side length? I have to root, you betcha. This is what we did yesterday. I want to find the side length of the square. So we're going to root both sides. On this side, the square root of c squared is just c. On this side, the square root of 13 is, this is where you're going to want your calculators out, 3.606056. And when we're actually doing this kind of stuff, I'm going to round this guy now to 1 decimal place. We're going to call that 3.6 equals c. So we've used the Pythagorean theorem to find the unknown side length of a right triangle. Sorry? Then this hour will have been entirely pointless. That's not true. You're learning things. Your brain is expanding. Whether you never use the Pythagorean theorem again is okay. I'm still going to try and teach it to you. I was being sarcastic. Sorry, Gershon? It's not useless. No, it's not useless. Here we go. So I've got another example I'm going to give you here. Let's label those sides. The only side label that really matters is, and C is, the side that is 9, you betcha. It's the one that's across from the 90. So then I can call the other ones A and B. I don't know, let's call this one A and that one B. I don't know. It's 50-50. So far we're just 2 for 2. So what equation am I going to use now? Louder, Gershon? Well, based on my labeling, which side do we not know? So we're going to start with B. B squared equals C squared minus A squared. So we're going to go up here. Because it's a unit on exponents, and we're finding areas. So B squared is going to equal, C is 9. So it's going to be 9 squared minus 5 squared. So then B squared is going to equal 9 squared is? Hayden, I want your phone up here, please. You make the long march of shame. You're not the first person I've asked to put their phone away. 5 is? So B squared is going to equal, what's 81 minus 25? So then how do I find B? Square root. So the square root here is going to be 7.4833. So we're going to round that sucker to 7.5. There is that unknown side length. Not too bad, eh? What's slope? It's coming. 2 chapters, yeah. 3 chapters. We're going to do polynomials, then we're going to do algebra, then we're going to do slope. Okay, questions about what I've just done? If there are no questions, flip the page. I want you guys to do the following questions. B, C, and D. I am going to give you, what time does block end?
1:15.
You are. So I'm going to give you 6 minutes to do these 3 questions. And then I'm going to do one more example, and you'll have the rest of the class to play with the following questions. No. Not yet. But I want you to just sit at your desk right now and crank out these 3 questions. I circled B, C, and D, Raven. Then I'm going to do one more example with you. about word problems in the Pythagorean theorem.
Use a calculator.
A calculator would be useful to you, yes.
I think you should give a review all.
So Brielle, come get a calculator.
Marcus. So, since we're doing this one, alpha. Oh, just straight. That just says D.
Hey, language.
I did it.
Did you not? Okay. I thought you did. Okay.
Oh, that's it?
No. Square A. Square B. Add them together.
Wait, so 48 plus 14.
No. No. You have to square them first.
So 14 squared plus 48 squared?
C is always the hypotenuse. The hypotenuse is always across from the right angle.
2,500. No. Wow, you didn't let me finish it.
Not a two-line slate calculator. Nope. You're not using the equation the way I did it. Back to what we did. You didn't square these. You subtract them. Plug into the equation, use the equation.
You're not done yet.
Sean, I laid it out a particular way, step by step. Follow that method. Did you get 8? That's right. This one. Oh, wait a second. No, you didn't. Wait, you did. That might be right, even though the picture looks wrong. Oh, no, you did. You did oops. Let's take a look at what you did here. Oh, you did. What is that?
Equals 50.
You guys need your own school supplies.
Great question.
Your answer is 50, which is correct.
Okay. Try now.
You need to work on neatening up your writing there a little bit, Jackson.
I can't with this thing. I could with a pencil.
You can write neatly with a dodgeball. You can dodge a wrench. You can dodge a ball. You can write neatly with a pencil. You can write neatly with a highlighter.
That's actually a lot harder.
Can I dodge a wrench?
I would hope so.
Depends on how fast the wrench is going.
Well, you can dodge.
No, you can dodge. No, assuming all things being equal. If I huck the ball at you and you can dodge it, and if I huck a wrench at you, you should also be able to dodge that.
So what if you throw it better than you shoot the ball?
Assuming all things being equal.
Okay, but what if they're all equal then like 100
miles
an
Keep
hour?
going,
Are you gonna
Marcus.
then I wouldn't be able to
Am I
dodge
gonna
the ball, so I won't be able to dodge the wrench.
The issue is there. Sometimes the temptation to chuck a
What if
wrench
you throw?
is there.
What if the wrench goes back there like a boomerang?
I don't think that's how it works.
Wait, did you say you don't throw a wrench?
No, I didn't say it. I said the temptation was there sometimes.
What?
Because I've been tempted to throw a wrench at you. will not start now.
They're saying you want to hit a student.
Yeah.
I didn't say that. I said attempted. To allow a wrench to hit you. Not you, Jackson. But not you. This is what we're talking about. Metaphor. Dodge wrench.
Yeah.
Wow.
Oh my gosh.
Wait, but
Never mind.
I've
Don't
never-
even worry about it. You know what a metaphor is?
Oh, metaphor. I thought you said metaphor.
Speaking metaphorically. Is speaking in metaphor. No, I am not gonna throw a wrench at Jackson. I have never wanted to throw a wrench at Jackson.
You said
Are you done?
I would stuff like that on
Your answers are 50,
on my
6,
my
and
dad.
I've studied on what we're saying.
56 and getting there. Get to work. I'm not talking to you until you've done at least one question. Yes, how may I help you? 6?
Except for the walk.
That is correct.
I know tonight, I don't know
This is correct.
but it-
Marcus, you done all 3?
Yep.
No, you're not done. Last one. You should need an answer.
I actually got the answer at 12.
Oh, you did put it there. You did 6 and 12.
Thanks for telling me. Thanks for telling me. I still have to show the work.
Yes, that. I'll say the answer that's no good.
My God.
Well,
Oh my god, I got the answer, but I didn't know how to show my work, so I literally just started writing down right over it. I actually did that one.
Your work?
Yeah. Because I had the answer, because I used my calculator and didn't write down the work, and I didn't want to go back through all, so I just did random work.
this is work, and you're gonna use 2 keys. You gotta be careful which phrase you use. On the 2, you label the side. This side.
Probably looks like I'm just repeating out the same looks like you. Okay, so wait, on this one, so would it be, just say this is
Actually, if you're looking
A,
for A,
X is A, and A is B, so would it be, 10 or C
which one?
squared
One of them is
minus
50, one of them is
squared.
6, and 12.
That would just, okay, would it be 10
56 and 12.
or would it
Yes.
be
No,
A
it
equals
would be
10 squared?
Yeah, if it's C squared, that's A squared plus B
minus
squared.
A squared.
Make sure you're writing down the equations
10
properly.
squared minus.
There's 3 that we're going to use. A squared plus B squared equals C squared. C squared minus B squared is A squared. And C squared minus A squared is B squared. Make sure you're using the right equation.
Minus A
Huh?
squared?
Right, hold on.
10 equals 36.
Where was that?
I know what to do,
Can you
Marcus.
calculate?
I know what to do, Marcus. Yes, Marcus. I already kind of knew that.
By the way.
That one should
You're
go.
almost done. You're done about this.
Yeah, 6 times 6 is 36.
Oh, yeah.
The other ones are. Okay, if you've done those 3, I will tell you what the answers are. You still need to be able to get there. I'm gonna do one more example real quick here. Okay, letter B, the answer x equals 50. Letter C, x equals 6. Letter D, x equals 12. The other 3 questions on there, in no particular order, are 16.9, 8, and 31.6. I'm going to pause you guys right now, whatever it is you're working on. I want you to flip page 1 further to page 21. We're going to do one example here, and then we're going to be done. Well, my lesson, you're not done. I'll be done teaching actively. Then I will come and help where needed. Let's do some word problems, because word problems are great. Every single chapter we do is going to have word problems of some degree. I know, right? So your exponent word problems look like Pythagoras word problems, and here they are. I'll do one example, the first one, and then your rest are on your own. The bottom rung of a ladder must be placed 2 meters from a wall. The ladder is 6 meters long. How far above the ground does the ladder touch the wall?
Wait, how did I get?
Let us, to make your life a lot easier, draw the question. Here's a wall. Here's the ground. In a perfect world, the wall and the ground are going to meet at what kind of angle? 90. I mean, yes, the Earth will settle. Will they always be square? No, but that's okay. For the sake of the problem, let's assume that they are. Now, we are going to place a ladder against the wall. If you've never done this, you put the feet down somewhere and then you lean the thing up.
Really?
Yes.
Oh.
Yeah, you don't really. Actually, that's not true. Not all ladders are put against the wall.
It's true. This one you do.
Why?
We are told that the bottom of the ladder, so there's our ladder leaning against the wall. It must be placed 2 meters from a wall, and the ladder we are told is 6 meters long. So let's label our picture with these two values, 2 and 6. Where do they go in the picture? The ladder is, no, these numbers, guys, 2 and 6. 2, Ruben. Ruben says 2 goes on the bottom. 2 is the distance between the wall and the base of the ladder. That is correct. So then 6 represents what? The length. No, it says the ladder is 6 meters long. It's the length of the ladder. That's the ladder. That's where the 6 goes. So we're looking for how far above the ground does the ladder touch the wall. We're looking for this distance. That is our unknown, which I will call, I don't know, let's label these things. Let's label the sides A, B, and C. Hayden, wake up. Where are we putting A, B, and C? Not just, Hayden, we're doing another question as an example. You should have a writing utensil in your hand. Which side do we want to call C? Yes, the 6. Which one do you want to call A, Jackson? The unknown? Yes. I also wanted to call that one A, so we are on the same page this time. And then the bottom we'll call B. So what is the equation that we're going to use to solve this? A squared equals C squared minus B squared. So, okay, so these equations that are given to you at the top of the page, I'm not going to give you these two. I'll give you the 3 I labeled to you before, but I won't give you these other two. A squared equals C squared minus B squared, and now let's fill this thing in. Side C is 6 long, so A squared is going to equal 6 squared minus, and B is 2, so it's going to be 2 squared. So A squared equals 36 minus 4. Yeah, this is how you show your work, Raven. You're writing here with me. Pick up your pencil. So then A squared is going to equal 32, Jackson said. You're correct. So then how do I find A? It's not going to be 5.6. You're so close. It's 5.6 what, Jackson?
Oh, 5.6568545.
Okay, let's stop there. I want to round this thing to 1 decimal place. So that is where I want to round it to. So this 5 is going to make that 6A. So the height of the wall, 5.7 meters. There it is. I would like you to finish the 3 hypotenuse questions I gave you on the previous, or not the hypotenuse pages questions, the 3 triangle questions I gave you on the previous page, B, C, and D. And then I want you to do all the word problems. This one, who's your guys? Mr. Abraham, see, Mr. Abraham doesn't even teach here anymore. He's sick. So, actually he's not sick, he blew out his knee. Who is your guys' favorite PE teacher right now?
Mr. McQueen.
McQuinney?
I only have one.
Okay.
Actually, Mr. Funny.
Is there a teacher named a PE teacher?
Mr. Winnie?
It's McWinney.
I thought you said Mr. Winnie.
No, Mr. McWinney. I don't know how to spell it. Is there a PE teacher named Mr. McDonald?
Yeah, he's my PE
Oh, yeah.
teacher.
Okay. I don't know who that is.
Is that the blonde?
So McWinney is going to get you guys, he gives you a choice. You can either run diagonally across the field 3 times, or you can run the perimeter once. How do you find the perimeter of a shape? You add up all the sides. It's all the way around. Then Mr. Easton's going to buy a TV. Gurman is gonna go kite flying with Jacob, and Taylor is going to leave her house walking. These are draw pictures for these. You may now work on the board if you would like, yes. I will help, or Shobit can help, whoever is in need.
So you literally don't know how to do any.
I know how to do A.
Then you know how to do that.
I just realized this is the Abby
Then I know how to do that.
Yeah. I'm pretty sure it's a Google Maps take off our field.
I just